So recently I had to do some multiplication by hand because I didn't have my phone on me. And as I was doing it, it occurred to me that I didn't really know why what I was doing worked. What I was doing was that multiplication algorithm, that thing we learned in elementary school, is called long multiplication. And it's that whole you multiply right to left and add carries and stuff. I don't know if I just didn't care or my brain thought it was unnecessary or something like that, but I actually had no idea how it worked. And so after doing a bit of research and just thinking about the problem and working through it, the way it works is that we calculate a bunch of partial products, we add them back up, and that gets us our answer. What this is saying is that if you have a big number and you're multiplying by some other number, one way you can get the answer is by multiplying it directly. And by multiplying it directly, you can just think of it as repeated addition. So you just add it over and over however many times. Or say you break down that big number into a bunch of smaller numbers, say 3,920 and 8, using each of the digits of the number. And then if you multiply each of these smaller numbers by the other number, which in this example is much easier since it's effectively a single digit number multiplication times some power of 10, and then add each of those partial products up, you should get the same answer as if you multiplied directly. And to kind of give you a feel for why that might work, it's kind of like that one time one of your friends saw a really good sale on lotion at Costco, but there was a limit of 2 bottles per person, so they hit you and your 6 other friends up and were like, "Hey, can you come along and also buy lotion and give them to me?" Whether all of you guys went together at the same time and bought 2 bottles each, or if you all went separately on your own, or maybe together with some other friends and then each got 2 bottles, either way, there would have been a total of 14 bottles of lotion. A visual example of this is, imagine you had a line and you wanted to stretch it twice as long. Whether you stretch that line twice as long directly, or if you cut that line up into smaller pieces, stretch each piece twice as long, and then add them back up together, you'll get the same length line either way. Something that's also cool about long multiplication is it has the property of you being able to add partial products as you calculate them, and only needing to remember the carry, so you don't actually have to remember too much. But yeah, let's take a look at what I mean about us not needing to remember too much. On screen, we have all the partial products we actually calculate when we do long multiplication, except instead of adding things right away, we save them all up to add at the very end. If you pause and play with this long enough, you should be able to see why calculating each partial product corresponds with us being able to calculate a digit to our answer, assuming we went right to left. The only information we need to calculate the green column is what the partial product's value is in that column, the previous partial product's value in that column, and any long addition carry we may have had from calculating all the previous digits. So at a high level, we covered why long multiplication works. We break up our problem into a series of smaller, easier multiplication problems, and then add them back up. We also covered some of the details, such as why can we write numbers down as we calculate partial products, and what exactly the carry is in long multiplication. The last remaining major thing we haven't talked about is exactly what are those placeholders you get when you multiply by a multiple digit number. And for this, we can just look at our previous examples, except we flip the numbers around. On the screen, we can see that even though we flip the numbers around, we get the same exact partial products as before. And hopefully this is a good illustration for where those placeholders come in from. So basically when you're multiplying the 2 to the 7 in long multiplication, it's not really just a 2, it's a 20. And then for the 9, it's not really just a 9, it's actually a 900. So that's why you need to add in those zeros when you're doing 7 times 9. It's true that multiplication is core to so many things in our daily life. It's easy to think of it as some mundane, basic thing for babies. It's everywhere from something as obvious as calculating how much money we owe for dinner, to powering video games, to powering massive machine learning models. But how we reach that destination of calculating the multiplication to do all of that has a pretty complicated but pretty cool answer. Alright, well that's about it for this video. I'm playing with different styles and content to cover, so if this video made you feel some sort of way, or if you had some ideas or topics you'd like me to cover, please let me know in the comments below. Until then, I'll see you guys in the next video. Bye!